Section 5.6, inequalities in one triangle, and we're going to use them to decide about angles and sides. The first one is the comparison property of inequality. If A equals B plus C and C is greater than 0, then A is greater than B. So if you have a side that equals two other sides added together, wouldn't the side on the left, like A, be bigger than both of those separately? So if you add two things together, the thing that's bigger will always be bigger, kind of is what that one says. The second one, the corollary to the triangle exterior angle theorem, the measure of an exterior angle of a triangle is greater than the measure of each of the remote interiors. And this is kind of that same theory. So we know that 1 is equal to 2 plus 3 because we had an exterior angle theorem before. If 1 is on the outside and it's equal to 2 plus 3, it has to be bigger than them both separately. Okay, so 1 is going to be bigger than 2, and 1 is also going to be bigger than 3 because the two added together equal 1. So it's kind of taking those two things and combining them together. So with this one, why is the measure of angle 2 bigger than the measure of angle 3? So when you look at that, first of all, you have to see where those two things are that you are comparing. And let's kind of take this and break it apart. So these two sides that are marked the same are BC and DC. So BC goes with 2 and DC goes with 1. Okay, so that's what you're looking at. They're not equal to the lengths of the sides, they're just equal to each other. So 1 and 2 are the same. We want to know why 2 is bigger than 3. So when we look at it, is 2 on the outside of the triangle that has 3 in it or the inside? Outside. So is the outside angle bigger or smaller than the inside? Bigger. So 2 has to be bigger than 3 because of that comparison that we just did. So when you look at this one, the one on the outside is bigger than the ones on the inside that are not touching it. Okay, so 2 is bigger than 3 because it is an exterior angle, and no, we don't need the and part. Okay, so 2 is bigger than 3 because it is an exterior angle, and it is always larger than the remote interior angles. You could probably put it's an exterior angle and then put the corollary to the triangle exterior angle theorem if you want to write those words, but it's just as many words as what I just wrote. So now, did it matter that I marked 1 and 2 the same? Not really on this one, but that's kind of something that it stands out. Mark them and go from there. So basically, sometimes there's going to be two smaller triangles within a big one. You're looking at all of them kind of at the same time. Since 2 and 3 were kind of inside the bigger one, I didn't look at the large one. I only looked at the smaller ones. Oh, actually, we do need that. 1 is really the exterior angle. 2 is not, because 1 kind of comes off the side and it has to be straight out like that. So since 1 and 2 are the same, 1 is an exterior angle, 2 is the same as it. That's why it's bigger. Okay, so we should say that too. Angle 1 congruent to angle 2. And I'm going to change it to angle 1. There we go. That looks better. Sorry about that. When you are looking for the exterior angles, you have to go straight out from a side. When I'm looking at this one, 2 does not go straight out from here. It doesn't do that. So that's why we did have to use that other part of it. Okay. Y is 5 bigger than angle C. So I'm going to bring this back down, make it a little smaller. Y is angle 5 bigger than angle C. So when I look at this one, the part I'm looking at is right here. 5 is here. C is over here. So here's C. Is 5 an exterior angle, first of all? Yes. And it's straight out, right? So when I follow this side straight out from here, it does go straight out. It's not like ending at an angle. So 5 is an exterior angle. C is an interior angle. And it is a remote one. Okay, so anything on the outside is always bigger than the things on the inside. And you could just say 5 is an exterior angle, angle C is a remote interior angle. That's it. That's all you need. Look at only the parts you need, not the parts you don't, because there's a lot of extra stuff in there. The 3 and the 4 and the 1 are all kind of extra stuff on this one. Then we hit theorem 510. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So they're not congruent. Angles and sides are never the same. It always chooses which one is the biggest. So when you're looking at this one, XZ is the biggest side. It goes with the biggest angle. So it's always opposite the side that goes with it. Okay, so we're going to kind of use that. And you can put them in order. You can just say this one's bigger than that one. You can do kind of a lot of things with this one. So a town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? So they want to find the largest angle. So when we're looking at it, which is the longest side? 175, 120, or 105? Okay, so you find the longest side and you go opposite that one. So basically, you're going to choose the angle that it doesn't touch. So you can't choose this angle, you can't choose that one, you're going to go straight across. So this angle right here is the largest angle. The two streets that make that up would be MLK Boulevard. Let's see, angle with MLK Boulevard and Valley Road. Okay, so that's all you do. Find the longest side. The angle that's biggest is opposite that one. Same thing would be if we wanted to do the smallest angle, we would look for the shortest side, which is 105, and we would go straight across from it. So it would be those two between Hollingsworth and Valley. Okay, so super, super easy concept. I think we kind of talked about that. Theorem 511, if two angles of a triangle are not congruent, then the longer side lies opposite the largest angle. So these basically go hand in hand. If you look for the longest side, the largest angle would be opposite. If you look for the biggest angle, the longest side would be opposite that one. So they're basically the same concept. One has the angle first, the other has the side. So with this one, they want us to put the sides in order from shortest to longest. So first thing we need is, how much is that missing angle? We know that angles of a triangle add up to 180. So 180 minus 58 minus 62 is 60. So the first thing I'm going to do is find out what that one is that's missing, and then I can put them in order. So they want shortest to longest. So which one is the smallest angle? Okay, so this one. So I'm going to put angle U is first. Then we go to they want the side. This one, let's go like this. That goes with which side? TV. So if U is the littlest angle, TV must be the shortest side. Then we go to the next one, 60 or 62? 60 is the next one, so angle T would be next. Which side is opposite angle T? UV. Would it matter if I switch the order of the letters? No. And then angle V is the biggest one, and that one goes with this side, so we can say TU or UT. So in order, smallest to biggest would be those three sides. Would you have to do it like I did? No. If you look at it and you do angle U is the smallest, I'm going to write down VT first. Go for it. You don't have to pair them up with sides and angles. They're not congruent. You're just finding the ones that kind of go together. So shortest to longest. Most of the time they do short to long. Sometimes they'll throw in longest to shortest, but you just kind of have to read and pay attention. If there's an angle that's missing, find it. With sides, the only way they could leave a side missing is if it was a right triangle, and you could use the Pythagorean theorem to do that. Okay? Otherwise, they'll always give you all the sides. For three segments to form a triangle, their lengths must be related in a certain way. Only one of the sets of triangles below can form a triangle. The sum of the smallest two lengths must be greater than the greatest length. So with this one, they have 3, 3, and 5. That forms a triangle. The other one, 2, 2, and 6, does not form a triangle because when you make those, with this one, 3 plus 3 is bigger than 5. That makes it work. With this one, 2 plus 2 is not bigger than 6. The sides don't meet. So this length down here is too big for those two things to meet each other. Okay, so we're going to have a theorem or something next here that tells us why that is. So we are looking for the sides, and it has to be bigger than the longest one. Okay, so triangle inequality theorem, theorem 512. The sum of the lengths of any two sides of a triangle is greater than the length of the third one. Basically, you probably didn't need to put those. If you did, I guess it's okay. But you are adding all the pairs of opposite sides together, two at a time, and every single one of them has to be bigger than the other side. If there's one that doesn't work, then it's not a triangle. Okay, so let's look at one of these. 3, 7, and 8. So I'm going to start just taking the first two. Is 3 plus 7 bigger than 8? Yeah, you don't have to simplify that down to 10. Just keep it like it is. I like to see the two lengths that you're using, so this one's yes. Is 7 plus 8 bigger than 3? Yep. And is 3 plus 8 bigger than 7? Yep. So this one is yes, because of all three of those things that you have to write down on your paper. So it's going to say explain. Basically, this is your explanation. You don't have to use any words. You can just write them all down. Now, if there's one that doesn't work, let's say this length right here was 5. Is 3 plus 7 bigger than 5? No. Or, 3 plus 7 is bigger than 5. How about, I should have picked a bigger number. I think there's another one in the next one that you'll see that it doesn't work. If you find that and you see a no right away or anywhere in between, you don't have to finish it. So if there's a side that doesn't work, like let's say those two added together are smaller than that other one, or it doesn't make sense, then you're just going to say no. Okay, so the two added together have to be bigger than the other one. If they're not, you're just going to say no. Okay, so is 5 plus 10 bigger than 15? It's equal to 15. Now, greater than and equal to are not the same thing, so I'm just going to put a slash through it, and I'm going to say no. That's all you'd have to do. What if you didn't find that one until the second one or the third one? Doesn't matter. Whenever you see one that is false, the whole thing does not make sense. They would just basically not meet. And of course, it's all of this, not just the no. Here's a got it question. Can the triangle have this length side? Is 2 plus 6 bigger than 9? No. So again, you just say no right away, and this is your explanation. If it is equal to or less than, it is false. As long as it's bigger than, you're going to keep going and do all three lengths. How about this one? 4, 6, and 9. So is 4 plus 6 bigger than 9?
Yes.
Yep. Is 6 plus 9 bigger than 4? And then is 4 plus 9 bigger than 6? Yep. So all of these work. You're just going to say yes. Basically, it's all of them two at a time. So I always do the first two together, bigger than that one. The next two bigger than the first one. And the first and last one bigger than the middle one. You can do them in any order as long as you've got all three, if it works. To build a triangular sandbox with two of the sides, dimensions being 5 and 8, what is the range of possible lengths for the third side? So they want a range of values that will make that triangular sandbox work. Okay, so they're not giving us the third one this time. So our values are 5, 8, and we don't know. So we're going to call it x. So we have to write down all of the things. Two of them together are going to form a range of values like between 6 and 9 or 12 and 50 or whatever. So we're going to go like this. 5 plus 8 has to be bigger than x. So I'm taking it exactly like I did on the last few, except we have a variable in there. Okay, the next one would be, is 8 plus x bigger than 5? And then the last one would be, is 5 plus x bigger than 8? So you're going to have three different things that you write down. Then we're going to solve them. One of them will not make sense, okay, and we'll find it here in a second. 5 plus 8 is 13. That one looks okay. So we're going to kind of underline that one. If I solve this thing for x, I'm going to subtract 8. So that says x is bigger than a negative 3. Well, when you're talking board length, can you have negative numbers? No. The one that doesn't make sense is going to be the one that has your negative numbers in there because you're talking actual board length. With this one, we're going to subtract 5. And that one works as well. So now the hardest part is putting it in a range of values. Here's how it works. You're going to put the smaller number on the left, which is 3, the bigger number on the right, which is 13. The x is going to go in the middle, and it's always going to be less than symbols. Now let's see if we can do that just looking at this. With this one, notice the 3 needs to be on the other side, so you're going to take the whole thing and flip it over. So with this one, it kind of looks like this. 3, and if it was a greater than, now it's going to be a less than x. That's why that looks like that. If you're looking at this one, the 13 is the bigger number, so I need to flip this over, the whole thing. That becomes x, and it was greater than, now it's less than 13. And that's how that becomes that one. So if you just remember that the smaller number is always on the left, bigger number on the right, small left, large right, always less than symbols. Okay? It doesn't matter what you think it is, it's always less than symbols there. And that's just like saying the triangular sandbox, the lengths that you would need to buy would be between 3 and 13 feet. So 3 feet and 13 feet, any of those would work and they would make that triangular sandbox. It would, it would just make, you have to kind of see what kind of room you have. Okay, so if you do not put it in a range of values, you will not get full credit there. Sorry, that went way back to the beginning. Okay, so has to be in a range of values at the end. Okay, how about this one? A triangle has side lengths 4 and 7. What are the possible lengths of the third one? So grab a piece of paper with your assignment, and I don't have the numbers up here yet, but put this one on there first and just leave it at the top of your page, and then I will put the numbers up there and you can kind of continue on after that. I just want to see who has that one.